Hi. So I realized that, not realized that, but some of you guys were asking me to go through these two slides, 19 and 20. So I thought I will do a little short video to illustrate that. Typically, a lot of the students had this issue with these two examples in the previous years. So it's not something new. So I hope that in this session I'll be able to go through with this, and you'll be able to understand a little bit more about what these two examples are saying. So the model that we are first looking at in first place is called the RAM model. So this is not especially what we call the big O analysis. It's actually not. In the RAM model, we assign a certain cost to each individual operation. I think we have seen right now in the lectures and the tutorials that many times you also use the big O notation to find out what is the time complexity of a certain algorithm. I would say that typically that is what is normally done. So maybe your question is, why are we learning about this RAM model? One important thing is that it is again one of the fundamental skills that it's good to build. So as I shared earlier, typically in quizzes, exams, these type of questions will be able to test a little bit more about your understanding in a step-by-step basis. Whereas sometimes in the big O notation, it's usually a binary. You can either get it wrong or correct. Yeah, neither half. Yeah, won't get it halfway right. Whereas if you do the RAM model, there are many chances for you to get parts of it correct. So it's better for us to assess your understanding. Okay, so let's look at example 1, where we talk only about this one sum. In this one sum, what this function is doing is that it is initializing a certain value of sum. It is iterating through the value of in the array, and then iterating through a value from 0 to n minus 1. And if the value of the array at the index is equals to 0, I would add a value of 1. So let's look at it from an English perspective, right? In the English perspective, what this function is doing is to count the number of zeros in my array A. So in English, this is what this function is doing. Okay, so this is the first point I want to make. Okay, so with that, let us go and see what is the cost of this function of counting the number of zeros in my array. We analyze them line by line by line. We have looked at the RAM model initially. It says that the assignment has a cost of 1 unit cost. Okay. So assignment has a unit cost. The second thing is the following. The second thing is this for loop. Let's look at this for loop. Okay. I understand that this is in Python, that if we analyze the program in a typical fashion, we have a for loop. We iterate from I equals to 0. In this case, right, it is range n, which means that I will take the value of 0, 1, 2, all the way up to n minus 1. Okay. In the typical for loop, what happens is that every time my I is incremented, I would check back to see if my I has exceeded a certain number. And in this case, it checks if my I is it less than n minus 1. Okay, so every single time I goes into this line, it does this check. So what this means is that from 0 to n minus 1, this occurs n times. So from 0 to n minus 1, there are n number of elements. But we also want to do a final check to see if has my I exceeded my limit or not. Hence, in this for loop in range comparison, we have n plus 1 comparisons. Not n comparisons, but n plus 1. So the for loop statement occurs for n plus 1 times. And I can't close this. Okay, let's do this again. My for loop statement occurs m plus 1 times. Okay, so this occurs 1 time. This is my sum. So now I understand that this occurs m plus 1 times, but the number of times this occurs is only n. Correct? Because the last time the loop, it doesn't go into the loop. So this portion only occurs n times. What this means is that this check also occurs n times. In this check, what happens is we will be doing two different instructions. Every time my if statement is being run, it will first execute my array access, followed by a if equal comparison. Every time goes into this loop, this if statement runs, and so my if comparison will run for n times, and my array access will also run for n times, which is why I have n and n of 1 here. Finally, we have this increment. This increment, in the best case scenario, or not in the best case, I can call it in the best case scenario, all my elements in A, they are non-zero, and so this runs for 0 times. That's my best case, where all my elements in my array A, they are non-zero elements, and so it runs for 0 times. How about in the worst case scenario? In the worst case scenario, every single element here is a 0. So I have n number of elements in A, and every element is the numeric number 0. And if every single element is the numeric 0, this line is going to run for n times. And so this line runs from 0 to n. Hence, this should be 0 to n. Okay. If I sum up my minimum array, this, and 0, it will be 1 plus m plus 1 plus n plus n, which is 3n plus 2. So this is the minimum. If I do the maximum, it will be this, and n, which is 1 plus m plus 1 plus n plus n plus n, which is equals to 4n plus 2. And so the total cost of this operation will be from a range of 3n plus 2 all the way to 4n plus 2. Okay, let's look at the other example. Okay. So this is a little bit more complex. So what happened? Well, okay, let's again look at this in English. What in English is this trying to do? In English, what is this trying to do is the following. It's saying that I now have two arrays. Array, or rather I want array A, and I want to check that are there any two elements in my array that sum up to the value of 0. Okay? Are there two elements in my array that sum up to the value of 0? And how I check is that from this number, I'll check if for this number from here until here, any of these two sum up to 0. For this number, next one, this number, I'll check here, does any sum to 0? And so on, the check will continue, and so on and so forth. So in English, this is what I'm trying to do. I'm trying to find if how many pairs sum to 0. How many pairs of numbers in my array A sum to 0? That is the intention of this function. Okay, I'm clearing. Let's clear this. Okay. So let's go to this function step by step. Okay. This is what we've seen earlier. So this is slightly straightforward. So this is just cost of 1, which is what you see over here. So this should be fine. Okay. This one is a little bit more complex. So I think in the lectures we didn't cover this yet. But let's cover this, and this. Okay. Let us come to somewhat of an agreement. Okay. This will occur, let's say, I don't know how many times it occurs for, but let's assume that it occurs for X number of times. Okay, let's assume that it occurs for X number of times. I hope everybody will be in the same agreement to say that if this occurs X number of times, this will occur X number of times. This array access will occur X number of times. This will also occur X number of times. And this will occur 0 to X number of times. Okay. So I hope we are all in this agreement. So for now, I don't know what is my X, but I know this will be the ratio of times it occurs. Okay. So I don't know what's my x. So let's not look at these numbers first. But now I know that this occurs x number of times. Increments, this is my equal. My array access, which is a, I, and my a, j, each of them will occur x number of times. And so together, it will be 2x number of times. My sum is going to occur 0 to x number of times. So I hope we are all in the same agreement. This will occur x number of times, this will occur 2x number of times, and this will occur x number of times. X is the number of times it goes into my second for loop. And I don't know what is my value of x for the time. Okay. So I hope everybody is in kind of agreement together with that. Let's go a little bit further into this. So once again, x, 2x, and x. Let's look at this line right now. I want to look at my for range and my j range. Earlier, what we have established is the following. I is going to go from 0, 1, 2, all the way to m minus 1. And you will check if the condition has reached n or not. So recall in our earlier one sum, this occurs for n times. There's one extra time for the check. So this loop of this upper loop goes for n plus 1 times. So my upper loop goes for n plus 1 times. Okay, that's good. So it goes into the following n times, but let's look at this in a little bit of let's say like detail how this may work. So when I is equals to 0, maybe let's do this. Okay, so this is fine. We know that this is m plus 1 time. We know that this is m plus 1 time. And let's say I and j. When I equals to 0, j will take the value from 1 all the way to n. When I equals to 1, j will take from 2 to n, and 2 will be 3 to n. 3 all the way to m minus 1, where it will take from n to n. Okay. So this runs for n number of times. 1 to n runs for n number of times. This will run for n minus 1 number of times. This will run for n minus 2 number of times. And this is n all the way to 0 number of times. Okay. Okay. So in my inner loop, what happens is that I now have a arithmetic progression from n all the way to 0. And so the formula of this AP is going to be half of n plus 1. This is my inner J loop. This is the formula for AP, which you can check out earlier. This is that of my inner J loop. I know that my inner outer I loop runs on n plus 1 time. So in total, the number of times that these two run for will be half n plus 1 plus n plus 1. So if you work this out, it will be half of n squared plus half of n plus m plus 1 equals to half n squared plus 3 over 2m plus 1 equals to half of n plus 3 plus 1, which is what we have over here. Okay, so this is the one of the harder parts to understand. But once we understand that, then everything seems to be a little bit easier. Now we look at how many times this line goes in. Okay. So we have analyzed this. We know that this is x, 2x and x. Now we want to find what's my value of x. I'm going to erase some stuff. I'm not using the erase all because I want the things on top. Okay. Now we are going to find out how many times it goes into this part. Okay. As I said earlier, when I equals to j, when I equals to 0, j takes the value of j 1, 2, 3, 4, 5 all the way. It will stop at n. But the last value is actually not n. The last value is n minus 1. So in here, j will go from 1 all the way to n minus 1 when it enters into this for loop. Over here, you will go from 2 all the way until n minus 1 and 3 all the way until n minus 1. Okay. Lastly, you will go from n minus 1 all the way to n minus 1. So only 1. Okay. So this runs for n minus 1 time is n minus 2 all the way until 1. Okay. So once again, this is a AP, but now the ending is n minus 1. So if I have 0 all the way to n, the sum of this is equals to half n plus 1. But now I only want 0 all the way to n minus 1. So I need to sum n minus n, which is equals to half of n plus 1 minus n. Why I want the minus n? Because my my AP starts from n minus 1 and not n. Okay, so that's why I need to do a minus n over here. If I expand out the terms, it will be half m squared plus half of n minus n. So this will be half n squared minus half n equals to half n minus 1, which is what we see over here. Okay. So we have solved for this, we have solved for this, we have solved for this, so we know now x is this value. And by what we have established earlier, my array access is 2 times that of x, so it is n minus 1, and my increment goes from 0 to x, so it's 0 to half n minus 1. If we add this, and 0, we will get the minimal value here. If we add this, and this one, we'll get the maximum value here. And that is actually how we solve for the two examples in slide 19 and 20. So I hope this is clearer for you, and let me know if there's anything else I can help out with. Thank you so much.